Hello friends, welcome to Susan and John MATRICES. In this video, we are going to continue our discussion about consistency of linear equations. In the last video, we learned that given a system of linear equations, we will be able to solve them or maybe not solve. But we don't use those words, we simply say the system will be consistent or inconsistent. And we even learned that consistency means it can be unique solution and it may be about infinite number of solution. And the conditions are if rank of C not equal to rank of A, then inconsistent. That means no solution. And if rank of C equal to rank of A, then the system will be consistent. And if this quantity is equal to n, then unique solution, and if it is less than n, then infinite solution. Okay, so let's try out one question. So please write test for consistency. So you can note down the system. And if it is consistent, we have to solve them. So I hope you're really good with the theory behind solving equations with the help of matrices. So the first thing to do is we have to express the system in matrix form, that is Ax is equal to B. I told you in the last video that every linear equation system can be put in the form Ax equal to B, where A will be the coefficient matrix. So can you tell me the coefficient matrix? Yeah, the one which comes along with x, y, z on the left side. That will be 3, 1, minus 4, and then 2, 5, 6, and the last row 1, minus 3, minus 8. And then our capital X stands for the number of unknowns which we are supposed to solve. We are trying to find the values of x, y, z. So capital X will be x, y, and z. And B, of course, is the right hand side, the constants, that is 0, 13, and minus 10. So look at this. The system can be put in the form Ax equal to B. And the next thing to do is we have to augment A and B and call it C. So that's the first thing to do. So C is equal to, I'm going to copy A over here. That will be 3, 1, minus 4, and then 2, 5, 6, and finally 1, minus 3, minus 8. And now we have to combine it with B, and that will be 0, 13, minus 10. So that is step number 1. So step number 1 means create the augmented matrix A, B. Okay. Now in step number 2, we will reduce C into echelon form. Remember, you're not allowed to use normal form because when we solve equations, we are not allowed to do any sort of column operations. That doesn't make any sense. Okay, so the next thing is I have to convert this into 1. So I have 3 options. Option number 1, I can multiply by 1 by 3. I can multiply the first row throughout by 1 by 3. But I don't like that option because this will become 1, but this will be 1 by 3 and this will be minus 4 by 3. We'll be creating a lot of fractions. Okay, we have 1 over here. So I think the best option is let us interchange R1 and R3. I had one more option. I can see 3 and 2. And I know 3 minus 2 is 1. So if I want, I can do R1 minus R2. That is why I told you I have 3 options, but I'm going for the easiest one, that is interchanging the last row and the first row. So I'm going to get 1 minus 3 minus 8 and then minus 10, and the last one will be 3 1 minus 4 and 0, and the one in the middle is 2 5 6 because it's not going to change, it's the same. Okay, now I have to make these two elements into 0 by using 1. So I'll write the operation, and I'm sure you're really good with the operation now. So R2 changes to R2 minus 2R1, and R3 changes to R3 minus 3R1. So look at this, 2 minus 2 into 1 and 3 minus 3 into 1. So the first row will be same, and the second row will be subject to this operation. So we are going to get 2 minus 2 0, 5 minus 6, that will be 5 plus 6, that is 11, and then 22, 13 plus 30, that will be 33, and 0, 1 plus 9, 10, minus 4 plus 24, that will be 20 and 30. Okay, now we have the first element 1, and all the elements beneath that 1 are 0. Now what I do is I will go to the second row and find the first non-zero element, and I have to convert it into 1, and that's very easy, and I can see multiples of 11, that makes it really easy. So R2 changes to R2 into 1 by 11. So I'll get 1 minus 3 minus 8 and minus 10, 0, 1, 2, 3. If you want, you can divide by 10, but I'm not going to do that. Okay, so the first element is 1, and beneath 1 all the elements are 0, and kind of like diagonally it is 1. So my next job is to make this character 0. So that is in R3. So R3 changes to R3 minus. So I know 10 minus 10 into 1 will be 0. So that is 10 R3. So 1 minus 3 minus 8 minus 10, and then 0, 1, 2, 3, because only the third row will change. So 0, 10 minus 10, 0, so 20 minus 20, and 30 minus 30. Okay, now look at this. We are already in echelon form, because we have 1 and all the elements below 1 are 0. The first non-zero element is 1 and all the elements beneath are 0. And I can already see that echelon over here, that pattern. Okay, so what is rank of C? Rank of C means the number of non-zero rows. That will be 2. Now what about rank of A? I told you that day, if you want to find rank of A, the simplest method is you just hide the last column. Okay, now you can see the rank of C is equal to 2 and rank of A is also equal to 2. So look at this, rank of A equal to rank of C, and that means the given system of equations are consistent. That means we will be able to solve it. But what is n? The number of unknowns, x, y, z. So that makes it 3. So this is actually less than n. That means we will end up with infinite number of solutions. So look at this. The rank value is equal to 2 and number of unknowns is equal to 3. And this means we are free to choose one variable, any arbitrary number. That means we have to solve for x, y and z, but you can put z equal to any number you like. I'm going to put a general constant k so that I can find the values of the others. So look at this, the first equation. Last I taught you how to read the equations from the most simplified version. So the first equation will be like x minus 3y minus 8z is equal to minus 10. And then the second equation is y plus 2z is equal to 3. And there is no third equation, but I told you rank equal to 2, n equal to 3. So n minus r is equal to 1. That means 3 minus 2 is equal to 1. And that implies you are free to choose any value you like for one variable. So I chose z equal to k. And since z is equal to k, I can find the value of y. Y plus 2k equal to 3. So y is equal to 3 minus 2k. So now I know y and z. So I'm going to put these values in the first equation. So I'm going to get x is equal to 3y plus 8z minus 10. And that is x is equal to 3 into 3 minus 2k plus 8 into k minus 10. And that gives me x is equal to, so this will be minus 6, and that will be 2k and 9 and minus 10 minus 1. So now look at this. This is the question. We were trying to check the consistency. Of course it is consistent because we found that rank of A is equal to rank of C. And we saw that this value is 2. But the number of unknowns were 3. So we know that there will be infinite number of solutions. And since it is infinite number of solutions, our answer will be always in terms of a constant. But remember, sometimes it will be in terms of one arbitrary constant, and sometimes it may be in terms of two arbitrary constants or more. And that will be decided by the numbers n and the rank. Here n is equal to 3 and rank is equal to 2. So n minus r is equal to 3 minus 2, 1. That is why our solution is in terms of one arbitrary constant, namely k. Okay, now I'll tell you what this implies. We can put any value for k. For example, if I put k equal to 0, look at this, I'll get a set of solutions minus 1, 3 and 0. This will balance this equation. So let's check it. So 3 into minus 1, that will be minus 3, and y is plus 3, and then the last one is 0, see, is equal to 0. The first equation is satisfied. Now let's try putting it in the second equation. So 2 into minus 1, that is minus 2, plus 15 plus 0. Wow, that's equal to 13. The second equation is satisfied. Similarly, minus 1 minus 3 into 3, 9. That last one is 0. So minus 10. The third equation is satisfied. So this is one set of solution. Now you imagine you put k equal to 1. If you put k equal to 1, you get another vector. That will be 2 into 1 minus 1, that is 1. 3 minus 2 into 1, that will be 1 and 1. Oh, that means this is another vector or another set of solution which will balance it. If you want, you can check it as earlier. So 3 plus 1, 4, 4 minus 4, 0. 2 plus 5, 7, 7 plus 6, 13. 1 minus 3 is minus 2, minus 2 minus 8 is minus 10. See, you can put k equal to 1 by 2, you can put k equal to 0.1, you can put k equal to 101.2, etc., etc. For every input of k, you will get a set of solution. So that is how infinite number of solutions will be dealt with. So let's try one more question, and that is extra important. I've seen it in many university question papers, and this question is very important because I have seen many students struggling to find the rank of this particular augmented matrix. So mark it important and please write. So we have another system, that is 5x plus 3y plus 7 z equal to 4, 3x plus 26y plus 2 z equal to 9, and 7x plus 2y plus 10 z equal to 5. So I'm not going to waste your time. We will start with the usual notations. Ax equal to b. A stands for the coefficient, x for the unknowns, that is x, y and z in this problem, and b will be the right hand side vector, that will be 4, 9, 5. Okay, so what we do first is we write the augmented matrix. We augment or we combine the matrices A and B, and that will be C is equal to, okay, now 5, 3, 7, and that's 4, 3, 26, 2 and 9, and 7, 2, 10, 5. Now look at this. You can use any technique you like to find the rank. The method is you have to convert this into 1, but take a look at this. If you try to make this 1, you'll be dividing this throughout by 5, or you'll be multiplying throughout by 1 by 5. And when you do that, you're going to get 1, but this will be 3 by 5, 7 by 5, 4 by 5. And then you'll subtract. And then your matrix will look horrible. It will be full of fractions. And the reason, these numbers are prime numbers, 5, 3 and 7. So you're going to make a huge mess if you don't know this trick. Okay, so you can try with your own method. Anyway, I'll give you one more trick. The trick is very easy. It's simply like solving equations. So what I'm planning to do is, I take a look at the number over here, 5. And I'm going to take a look at the next number, that is 3. So I'm going to write R1 changes to R1 into 3. That is the number just beneath it. And R2 changes to R2 into 5. So 5 into 3, that is 15, and then 9, then 21, and 4 into 3, that's a 12, and 3 into 5, 15. If you want, you can use calculator, but 25 into 5 is 125, then more 5, that will be 130, and 10, and 45, and this row remains the same. Okay, now what I do is something very simple. I'm going to do R2 changes to R2 minus R1. So look at this, 15 minus 15 will give me 0, and that is exactly what I wanted to do. So now 121, and then minus 11, and 33, and the last row remains the same. Okay, now tell me what to do. Okay, now what I'm going to do is I'm going to multiply this by 7 and this one by 15. If you want, you can do that, but as something easier than that, that is, I'll be multiplying because I can see something common here and I don't want the numbers to get extremely bigger. So here I'll write that. I'm going to write the operation. So R1 changes to R1 into, see, I can see something common here, and the common number is 15 by 3, 9 by 3, 21 by 3, so into 1 by 3. And when I do into 1 by 3, this will become 5. Remember, when I do 1 by 3, this will become 5. Anyway, I'm going to multiply this by 7, and I got that 7 from here. Okay, and then I'll multiply R3 into 5. And this is optional. If you want, you can multiply R2 into 1 by 11. That is optional. Okay, so 15 into 1 by 3, that is 5. 5 into 7, that will be 35. And then 9 by 3 is 3, and 3 into 7 is 21. And that's 7 into 7, 49. 4 into 7 will give me 28. And then 0 and 11, minus 1 and 3. This is purely optional. Okay, now look at this. I think you understood where I got this from. It's like R1 into 1 by 3. That's going to give me 5. And I'm multiplying this by 5 so that this will become 35. And a 10. And then 50. And then 25. Now look at this. I'm going to write R3 changes to R3 minus R1. So that will be 35, 21, 49, 28, 0, 11, minus 1 and a 3. Now I got my 0. That's exactly what I was expecting for a long time. And that is 1 and again a minus 3. Now one more step, and that will be R3 changes to R3 plus R2. So I'm going to get 35, 21, 49, 28, 0, 11, minus 1, 3, 0, minus 11 plus 11, 1 minus 0 and 0. Okay, anyway. After this video ends, please try out our usual technique, that is create 1 and then zeros and then diagonally create 1 and 0, that method, and check whether you like this method or that method. This method might be complicated for some of you. Anyway, I like this method. Look at this. The first element is non-zero. I didn't make it 1. I can make it 1 anytime. I have to divide by 35. And all the elements beneath that number is equal to 0. Then I move to the second row. The first non-zero element is 11. And the numbers beneath that are 0. So actually this is echelon form. And if I want, I can write one more step, that is dividing throughout by 35 and dividing throughout by 11. Anyway, our objective is not to express in echelon form but to solve the equation. So now you tell me, what is rank of C? I can see two non-zero rows, first and the second row, that means 2. Now what about rank of A? If you want to find the rank of A, what should you do? You forget about the last column. Yeah, again it is 2. Now the number of unknowns, X, Y and Z, that is equal to 3. So look at this. We have rank of C equal to rank of A. So that tells me the system is consistent. We will be able to solve. Now the question is, do we have unique solution or infinite solution? So I go for N. So look at this. This number is equal to 2. And I can see that N is 3. So they are not equal. So the answer is, it is consistent with infinite solution. Is that okay? Now, another question. How do you write infinite number of solutions? Writing infinite number of solutions is not possible. So what we do is, we write X and Y and Z in terms of arbitrary constants. And sometimes we'll be using one arbitrary constant, sometimes we'll be using 2 or more arbitrary constants. And the number of arbitrary constants depends on these two numbers. So n is equal to 3 and the common rank value is 2. And n minus r, that is equal to 1. So that means you are allowed to use one arbitrary constant. The first equation is 35x plus 21y plus 49z equal to 28. And the second is 11y minus z equal to 3. And no more equations. But I told you n equal to 3, r equal to 2. So n minus r is equal to 1. Unknown can be assigned any value you like. So I am going to assign z equal to k. And once I put z equal to k, I will get 11y equal to 3 plus k. And that means y is equal to 3 plus k, the whole divided by 11. Now I can put all these values in the first equation, and I'm going to get 35x is equal to 28 minus 21y and minus 49z, and I can take this 35 to the other side. I'll get by 35 by 35 and by 35, and on simplification you will get 35 minus 10k, the whole divided by 11. So this is our solution. So I'm going to stop the video here. I'll be back soon with another video in matrices, in which we'll be doing some very important problems related to consistency of equations. So till then, bye.